Every AI you've used, ChatGPT, the Face ID on your phone, the recommendation that got you binge watching something at 2 a.m., all of it comes down to one embarrassingly simple idea, which is drawing a line through a bunch of dots. That's it, that's the secret. Everything else is just that idea, repeated a few billions of times, with better bookkeeping. Most explainers start with machine learning is when computers learn from data, which is true, but it's also useless. It's like explaining a car by saying it's when metal moves. Technically correct, but zero intuition. So let's actually open the hood. A machine learning model is a math function with a bunch of adjustable knobs. Could be 12 knobs, could be 12 billion. Training a model means turning those knobs until the function's output matches reality as closely as possible. That's the whole game. Not thinking, not understanding, just knob turning. Here's the picture I want stuck in your head for the rest of this video. Imagine every possible setting of your model's knobs as a location on a landscape, and the height of the landscape at that point represents how wrong your model is. If you're high up, your model is making bad predictions. If you're in the valley, it's making good ones. Training a model is just releasing a ball on this landscape and letting gravity do the work. The ball naturally rolls toward lower ground, toward less wrongness. It has no idea what the bottom is. It just feels the slope under it right now and takes a step downhill. That's called gradient descent. I want you to notice the ball isn't smart. It's not reasoning about the landscape. It's just responding to slope over and over, thousands of times, until it ends up somewhere pretty good. And here's the part that should mess with your head a little. The ball might settle into a valley that isn't the best valley in the whole landscape. It just found a good spot, not necessarily the good spot. That's why two models trained on the same data can end up slightly different. Same rules, different roles. Let's make this concrete. This tiny script is predicting house prices from square footage. Two knobs, slope and intercept. Watch what happens when I run it. Every one of these steps is the ball rolling downhill. The last number going down the corner, that's literally the height of the landscape at the ball's current position. Now here's the wild part. GPT, the thing writing essays and code, is running on the exact same idea. Not two knobs, but hundreds of billions of them. Same landscape metaphor, same rolling ball, just an unimaginably higher dimension hill. We can't even visualize a hill with billion dimensions. Nobody can, but the math doesn't care. Slope is slope, whether it's in 2 dimensions or 2 billion. And here is why I think this framing matters, especially if you're a developer and not a researcher. When you understand that machine learning is curve fitting, a bunch of confusing stuff suddenly makes sense. The model isn't lying to you, it's just interpolating between data points is seen. And sometimes that interpolation lands somewhere false. It's a curve doing curve things, not a mind making choices. More dots on the scatter plot means the line has less room to guess wrong. A better fitting algorithm helps, but it can't save you from a landscape with barely any shape to it. A spam filter, a self-driving car's vision system, and the chatbot are all knob turning on different landscapes, built from different kinds of dots. Same underlying trick, wildly different costumes. And I think this is why I get uneasy every time someone says a model understands something. A ball rolling downhill doesn't understand gravity, it just responds to it. That doesn't mean these systems are useful. They are some of the most useful tools we've ever built, but useful and intelligent are different claims. One is about output and the other is about what's happening underneath. And underneath is still just a line, fit to some dots, in a space too big for any of us to picture. So next time someone tells you AI is magic, just picture this: a ball, a hill, and gravity. That's most of it. If you want to actually build one of these from scratch, no libraries, just the math, let me know in the comments and I will make that video next.